A very good afternoon, everyone. Welcome to the Singapore Geospatial Week Plus 2020 series of webinars. So with us today, we have Marek Suchocki. He's the Infrastructure Industry Engagement Lead from Autodesk. So he'll be joining us. He's actually tuning in all the way from UK, yeah? So without further ado, I'll hand this presentation over to Marek. Marek, please.
Thank you very much. I'm just going to share my screen. So can you please confirm that it's visible?
Yes.
Okay, so thank you very much for inviting Autodesk to present at the Singapore Geospatial Week Plus 2020. My name is Marek Suchocki, as the compere just mentioned. My focus is engagement with infrastructure owner-operators and their project teams, as well as actually information management standards. So understanding how project teams and asset owners use information for operation and obviously construction of built assets. The focus of this presentation is to talk about how Autodesk has worked with a third-party company, ESRI, to integrate our technology so that there is a seamless transfer of data from one set of technologies to another, as opposed to going through some translation. So, why do we need to do this? What is the requirement for improved use of BIM and GIS in projects and asset operations? So, to provide a little bit of context, for those people who are not familiar with BIM, BIM is effectively a three-dimensional model associated with extended attribution that allows a designer or a stakeholder to better understand the context of a proposal or a plan for construction, as well as the constructed assets. So it has a lot of detail in it. Whereas GIS, as many of you who are practitioners understand, is a spatial context, and it will be in a much wider view and perhaps lacking some of that finer detail. And we want to be able to actually share that information between the two groups so that a GIS user can consume model data within their the technology platforms. And similarly, a modeler, a BIM designer, can consume GIS reference data sets to create better context of their proposals and plans. And when we speak to different parties out there, they have different needs. So you can't say that a designer has the same understanding as an owner. So whether it's I want to design it in context, as I've mentioned, or I'd like to actually use a building model from handover to do spatial analyses and queries. You know, currently we're in the COVID-19 challenged world. It'd be great to use models to look at simulating different layouts of offices, of train stations, in order to maintain and preserve social distancing. So having that BIM data available in a spatial context and vice versa is really important, and it depends on your own perspective on the value you might determine from it. There are actually, however, some problems with this, and I'm looking back here at a report that came out over 15 years ago in America by the National Institute of Standards and Technology that talked about the cost of interoperability being 16 billion annually, of which nearly 11 was borne by the owner. So the fact that information was poorly exchanged between different systems and different technologies meant that there is an inherent cost in the translation and the associated errors from poor interoperability. Similarly, Barbara White Bryson prepared a very interesting book in 2010, and where she actually said that, you know, that ours, the construction industry, is the only trillion-dollar industry in the history of the world in which clients routinely demand the most inefficient processes creating the least value. And by what she meant by that is that by reinforcing the adversarial behaviors within construction projects, the poor handover of data, so sending the people after you 2D PDFs or perhaps a shapefile in a GIS context would mean that you're not actually giving the best information transfer possible. So what can we do about this? Well, at the moment, we need to fix these current workflows. So at the moment, information is not federated. So we're not bringing information together. Geographic data in particular can be stored in many different resources. And typically there is a challenge in sharing that information. Moreover, the wide user community doesn't know what's actually out there. They're not aware of the fact that there may well be valuable spatial data sets, or, I don't know, current traffic density information, and to allow them to make better decisions. Similarly, version management and the workflow is inconsistent, irrespective of which country or which industry sector you're working in, for the construction industry. And here is a kind of a very typical view where a user might say, oh, I'll phone up the GIS department to ask for some information, and they'll send me the shapefile. I'll have to then import that shapefile. So there's a potential risk of a translation error there. I may have to repeat this process because actually I didn't get what I needed because I wasn't aware there was another data set. And then eventually I'll build up my contextual model or design around it, and then I have to return the shapefile to the GIS department of the work that I have done. Now, that is a very typical current process, but you can imagine quickly that there are a few potential problems with information transfer or translation causing some errors. Let's look at a way that we can actually resolve some of at least the procedural issues, such as the ones that Barbara Bryson identified. So I am actually part of the British Standards Committee that's worked with the International Standards Organization to prepare the new ISO 19650 series of standards. And in the end of 2018, ISO 19650 parts 1 and 2 were published. Within part 2, information requirement obligations are stated. So here, the appointing party, so the client typically will establish the project's information requirements alongside each of the key decision points throughout the project. So when they need to make investment judgments, or are we doing the right thing? And in the standard, they identify a number of considerations that need to be introduced, such as the project plan of work, the scope, questions to which the party needs answers, such as, can I afford this? Is it the right size, etc. So there is guidance there to tell people that they need to set these things up at the beginning. So if you don't ask for the information you need up front, don't be surprised if you can't get it during or at the end of the project. Similarly, in the same section of the standard, it talks about how the appointing party shall establish the reference information and shared resources. So we're talking here about what information that they already hold that could be valuable for the project team to begin their work on. And also it talks about the avoiding duplication of effort and creating interoperability issues. So the standard is already giving guidance and recommendations on how the users and participants in a project can leverage data, but also specify their data needs. Just last month, part 3 of the ISO 19650 series was published, and this is focused on information management processes during the operational phase of assets. And again, within that standard, there is an annex which talks about numerous linked enterprise systems. And I think this is probably at the heart of that. I don't know what data's out there, but actually there could be many, many systems holding really valuable information. And I just took a stab at saying that some of these systems may already use or could use BIM or a common data environment to host information. So I've selected them there. And very similarly, systems could use GIS as a reference. And when you look at that coverage, it shows you that actually what we have here is a vast proportion of those linked enterprise systems could leverage either BIM and or GIS. So let's consider how we might connect BIM and GIS to address this demand. So from our perspective within Autodesk is we always see the entire asset lifecycle as being something that could be augmented by data and connectivity. And whether you're in the planning, the design, the build, or the operational phase, there is value in having good data. And we see a separation between where BIM is strong and GIS is strong. It doesn't mean that you can't use either system in the other phases, but actually GIS is stronger in the operational phase. Many, many asset owners have GIS systems to manage their asset estate, or as I said, data around traffic or other planning needs. And in the design and build phase, BIM is becoming even ever more predominant and valuable to designers and constructors, as well as to engage stakeholders to better understand what's going on. So Autodesk and ESRI a few years ago came together and said, well, we sit on both sides of this divide. Why don't we come closer together to help our user communities get better value out of data, because we want to go to a data at the center journey in order to not have to have these silos of information and silos of practice. So we've looked at a number of our technologies together and are adding functionality to mutually read each other's data sets. So let's start with how we might enhance BIM workflows. So the things I'm going to show you now are readily available within Autodesk technologies today. So here we are considering a contextual model around an urban area with a fluid. The designer here, he has modeled the urban context, and he's now going to recreate that bridge. He's going to show how he will use pulling the bridge design across and building up this context model with engineering information and data available to the designer. This designer is going to connect a data set from an ArcGIS to a section bridge model example. So he's looking at see what information is available. Manholes, and assigning it to the appropriate categories within the engineering toolkit. And we're now doing a of the screen. So now the designer has pulled in, as we say, some pipe work and manhole positions. And actually what could also happen is that somebody could go out in the field and say, well, some data. So this is using mobile technology and creating more asset data to do a job that we have a full record set. So this is a spatial data process that's being executed in the field. We've now added the data there and assigned particular categories of information. The thing here is that what we're getting here is the model. So this designer who felt that his bridge design is perfectly acceptable, he's doing an update, he's refreshing the screen, and what we'll see is that actually what's happened is that additional data has shown us that there is currently a very significant clash with the pipe going through one of the foundations of the bridge piers. So the designer now can quickly make an adjustment and ensure that that clash doesn't get manifested when the bridge gets constructed. So what we have done is we've done some very early consideration of potential clashes and fixed it in the context of the model, because we've got access to that rich, bang up to date GIS data. So the second example I'm going to show you here is where within our civil 3D, civil engineering application technology, we're similarly able to pull in information from ESRI ArcGIS data. So again, we're pulling in some pipework data, some feature lines, and essentially the modeler, the engineer here, he or she has the ability to access data and add it to their contextual design project. And similarly, they can set pipework diameters in this case, so that if that data doesn't exist within the ESRI source data, we can actually correctly create it when we're building a three-dimensional BIM model. And as you can see here, the attribution has come through from ArcGIS. So all the information, that rich data about these assets that was available in the ArcGIS system is available to the modeler. What's happening here is that the modeler has recognized that there was an error in the ArcGIS data, that some of that pipework and its manhole positions were in the wrong place. So he's corrected it, and now we do an update within the ArcGIS environment. So we've got a bi-directional sharing of information to ensure that we have accurate information, because it may have been poorly stored in the original design. In this case, the designer is now tracing a new pipe network for a new proposal, a new estate. And again, he or she, they're actually updating the information available in ArcGIS to include the features and in this case, a pipework, so that everything that is being proposed can now be added as a proposal within ArcGIS. So the owner, the appointing party using the language of the ISO 19650, they are now aware of the new suggested, in this case, estate. So we've got a bi-directional connection now, whether we're using the contextual modeling of the InfraWorks toolkit, or in this case, the Civil 3D Accurate Engineering, we can share information either taking data out of the ArcGIS environment or bringing it in. So let's now look at how the BIM data can be added to the GIS user. So what we have here is a Revit model, one of our BIM technologies, and the ArcGIS user here has been able to actually upload that data by pulling it in, and is now viewing this within a ArcGIS Pro scene. So we've now got BIM data readily available to a geospatial user. They may need to use this to understand the context of a proposal, or in this case, a delivered asset. But one thing that this particular illustration is going to show is how we can start adding attribution, because some of these attributes may not have existed in the original BIM model, but they can now be augmented and enhanced with the use of the ESRI toolkit. So we're now adding data, adding value for the asset owner of the kind of information that they want. And we're now doing a re-export back out into a CAD model. So the data that we've added will now be available to a user of a CAD tool. So effectively, we've got now a bidirectional share from a GIS back into the CAD world. And very shortly now, we're going to upload, in this case, AutoCAD view, and we're going to open up that file that has been edited by the GIS user. And again, as we can see, the new attributes that have been created by that GIS user. So my next example is more of the same in some respects, but now what we have is a scene in ArcGIS, and the user is now logging into the Autodesk Common Data Environment technology, BIM 360, and allowing them access to live current project data. So they can now start seeing what information has been created as the project, and they can navigate the folder structure within that common data system to pull it in and start using it as references within their GIS environment. So I'll let the scene upload now. So what we now have is a brand new proposal, similar to the one we showed earlier. In this case, it's a building proposal, and the GIS user now has full access to this data so that they can now navigate it in their ArcGIS. The ability to read and view and update that information from their GIS world. And also they can, load that data at some point, but they may be concerned that that data is no longer current. So we can actually do a check, is this data yes, no, and if it is current, they'll get an alert, or they'll be able to tell, no, you need to update that record because it's changed since you last referenced it. So what we have here is the ability to keep current data within either environment. I want to step forward. Oops. And then, so the last example here, now this is a newly developed, it's a pilot toolkit that ESRI are working on, which they'll launch, I believe, in the next 6 to 12 months. But again, no guarantees on when they might be able to get it. But now we're talking here about doing direct association of records in the GIS world with records in the Autodesk BIM 360 Common Data Environment world. So effectively, we're linking information, whether it's CAD drawings or in this case a full model. The GIS user can literally click on an item within their GIS environment and open up and view the data for that asset within the Autodesk BIM 360 toolkit. And by doing so, they then get to leverage all of the powerful model viewing, commenting, and analysis tools that any user of the BIM 360 environment has. So we've got the beauty of both sides of the project team, whether they're geospatial or model users, able to access the same good data and use the most appropriate tools to navigate and manipulate them. So in kind of basic conclusion, by connecting BIM and GIS, we get value through the entire asset lifecycle. So the designers shown here on the green side, they're able to be aware that data is available for them. They can actually connect to those features directly without doing any translation, update the information, refresh it, and keep good context of their proposal environment going, and design and build with confidence as stated here. And when the project is completed, they can publish those as-built features back into the geospatial environment. And so the geospatial user, they're aware now that there's good new data available. They can obviously cleanse it if need be, but that data is now not just the geospatial data, but it's also augmented with model and BIM data. So coming back to the work of Barbara Bryson, she said that BIM is the perfect complement to collaborative teams. And she also said, especially ones that care about the fluidity of information sharing and coordination, as opposed to the sanctity of drawings. So rather than talking about two-dimensional drawings or PDFs, what we're saying is, well, let's have that information being shared dynamically to improve project coordination and information sharing. And finally, I'll finish really with a comment from Jack Dangerman, the president and co-founder of ESRI. He actually said at the time when Autodesk and ESRI announced their alliance that it's not really about having open data, because any information that is shared is by its very nature open. It's about connecting those tools to other tools and at the data level, so that he said, bang, it just changes things. And with that, I'm pleased to say I finish and can be open to any questions.
Thank you so much, Marek, for that presentation. So perhaps we can move on to some questions and answer. I think we have probably about three questions right now. So I'll start off with the first one. For the audience, for those of you who wish to post a question for Marek, please post it in the Q&A box, not the chat box, please. Okay, thanks. So let's go on to the first question. Do users have to manually populate the metadata in the BIM? Oops. Marek, you're on mute.
Can you hear me now?
Yep.
Okay, apologies for that. Well, the answer is, I think I illustrated that they can populate the data within the model environment. So we have the facilities to do that using our modeling tools. So you can add attribution during that stage. You can actually also host and hold those attributes in related systems or databases. But with this partnership with the ESRI toolkit, what we can do is also add those attributes within the geospatial environment. So you can do it at the most appropriate time, because sometimes the modeler, the BIM user, doesn't know what that data needs to be. And sometimes it's the person in the geospatial world who knows what those attributes might be, because they could be obviously to do with an assets manager or so forth.
Okay. Next question. In your case study of the BIM GIS cyclic workflows, is there any rollback features to previous versions of a design?
So if I understand that, in the model environment, yes, if you use a toolkit such as the Autodesk BIM 360 platform, we effectively can hold previous versions of any model that have been shared or published for use. So it is possible to say, no, we've perhaps made a design proposal that's not suitable and we need to go back to an earlier stage. So that information is available. And again, if the geospatial user is connecting to that BIM 360 environment, they should be able to also identify the historic data that they might want to pull in if that was most appropriate. But I will basically say that the ISO 19650 approach that I talked about, that's the one that effectively allows you to control the release and use of project information. And you should use the most appropriate or current data set, even if that is bringing forward a historic data. So I think the answer in a short way is yes, but you need to consider the process, because you don't want to use out-of-date information, which could introduce error if it's not appropriate.
Okay. Next question. Are these BIM data generated automatically? If not, can you share your thoughts on how to assess the ROI for the manual data modeling?
Okay, so if I understand the question correctly, is there some way of automatically creating BIM models? Well, BIM is it's an engineering process. So it's a way of creating digital asset records from objects, library objects. So you effectively, rather than doing drawings, you're now creating a model. So that is a process that a designer, be they an architect or an engineer or another party, would go through. So they no longer create drawings, they're now creating models. And we can take drawings off of those models, so we can create drawings, but they are just a view of the model. So in that case, no, we're not doing things automatically, but we are using new technologies such as the Autodesk Revit platform or Civil 3D to pull model objects together and create a new design proposal. Having said that, we are also working in the domain of generative design and design automation, where we can use historic knowledge and rules to start creating some design proposals using the power of the computing technology that we have available today. So yes, there is capability to start using the computer to look at multiple options very rapidly, but obviously pulling in library objects to create those design proposals and guided by the designer. So increasingly we have some power to do some design automation.
Okay, the next question, 3D data size is huge. And what technology are you using to allow cloud transformation by having 3D data available on any device and anywhere, and to perform analytics, clip and ship on 3D data set?
Yeah, very good question. So what I hope I was able to show you is that in the ESRI user case, they were able to access what's known as the Autodesk BIM 360 environment. And BIM 360 is a cloud-hosted system for project participants and constructors. So they have information available in the cloud, and as you say, from any device. and that cloud-hosted system can consume very large 3D models. And again, as was shown, they can view those models, explore those models, and add commentary and queries to those models for response by the authors. It's the back end of cloud technology, which is enabled through something that we call Forge, which is our set of components that can be accessed and actually used by any other organization to make their own design and project solutions that allow this to be fed to whatever device you are, because effectively the user is receiving only a view on that. All the hard work of manipulating and opening the models is being done at the back end in our cloud environment. So it's effectively a chance to use our technology to do things that historically would have been very difficult, because indeed some of these 3D model sizes are very huge.
Okay, perhaps we'll have two more questions. The next one: how much details can both platforms work with, and what are the limitations of these model sizes, and so on?
Oh, well, I guess, you know, the detail they can hold is the same as they would have held in the past, you know. So if you're a geospatial expert and geospatial user of the, say, the ESRI environment, you'll have familiarity with the type of data sets that can be held, and you know, they can be massive, again, you know, covering entire nations, if not the entire globe. It's obviously the quality and the veracity, you know, the value of that data that needs to be considered. But you know, typically a municipality may well hold records about their roads, public facilities, and so forth. So that could easily be a very, very large data set. And similarly, at the detail level of the BIM and CAD data, it's what's appropriate. You know, we can design down to the fixtures and fittings and screws and so forth if needed for a particular modeled asset. But you know, when we're talking about civil infrastructure, roads, rail, or buildings, you're really modeling at the level that is appropriate to allow you to construct and manage an asset, and particularly also then to operate it. So you don't need huge detail, you just need to know perhaps who is the manufacturer and where you might be able to get more information about spare parts and so forth. So that's a big challenge, is knowing what level of detail you need to go to. Okay,
one last question for Marek. How does the word digital twin fit or compare with the integration between BIM and GIS?
Great question. Your digital twin is a kind of flavor of the month at the moment. Everybody's talking about them. I hope by going through some of these very quick examples, I've been able to show you that a foundation of digital twin is to have the right data available. So spatial data sets, which are already very prevalent, and the engineering and architectural design data sets that are available in BIM, these are at the heart of framing and managing a digital twin. So if you've got that data ready, you've got the foundations. And from that, you can now associate real-time information in use. You know where that data is associated with. You can bring in simulations. What if we change this road network? You can test it in the digital twin before you do it in the physical. So I'd say that what I've shown is the basics that you need to have in place, because if you don't have that, then all that other information has no context. So by blending GIS and BIM together, you're creating the context for making robust digital twins.
Thank you so much, Marek. We do have a few more questions actually, but we have unfortunately run out of time. So we have left Marek's email in the chat box. So if you do have those questions still unanswered, do connect with Marek through his email. With that, I would like to say a big thank you to Marek for joining joining us all the way from UK. And thank you so much for presenting on Autodesk. And for the audience, thank you so much for joining us. Do join us for our other webinars that are happening in the next few days. Once again, thank you so much, Marek. Thank you.
You're very welcome. Bye-bye.
Bye-bye.